Hello, in lesson 2, we talked about the concept of factorial. In this new lesson, I want us to talk about permutation. If you don't remember what factorial means, you can review lesson 2, then you come back to this one. So, basically, permutation means how can we arrange objects in a specific order. So, in permutation, order matters. Then, if, for example, let me show you with a simple example. Let's say I have 3 runners, Alice, Bob, and Carol. These 3 runners, I want to arrange them in order. As the first, who of course became the best, then the second best, then the third best. How many number of ways can I arrange these 3 runners? So you see, first, order matters here. Every time there must be one of the 3 must be take the first position, and then another one take the second position, and then another one take the third position, meaning there must always be order. So to do so, I can use, this is just like a repetition of permutation. So I can use, if I say, for example, in the first one, I can arrange them as Alice being the first, then Bob being the second, then Carol being the third one. Then again, I can arrange them as Alice being the first, Carol the second, then Bob the third one. That is the second arrangement. Then the third arrangement, I can arrange them as Bob being the first, then Alice the second, then Carol the third. Then again, I can also arrange them as Bob being the first, Carol being the second, then Alice the third. And then I can continue like that all the way to the 5th arrangement and even to the 6th arrangement. So I can arrange these runners in 6 different ways, which basically, instead of doing it all this manually, I can just take the runners are 3, so n is 3, then n factorial would be 3 by 2 by 1, which is 3 by 2 is 6, by 1 is 6. So I can arrange them in 6 different ways. That was just a review of factorial. So now we can go to the concept of permutation. So in permutation, what we mean is how many ways can we arrange n distinct items, a number of items from n distinct items. What I mean is, for example, if I have n number of items, I can say just 3. How many ways can I arrange 2 of these items and I retain order? So in this case, the formula for permutation is given by P, which is n meaning the total number of items, then R, the number of items you want to arrange out of the total items available, which is equals to n factorial, as we have revisited factorial there above, divided by n minus R, and now factorial. So this is the formula. So can we try this with an example? So if I ask you, how many ways can you arrange 2 books from 3 books? Those 3 books, of course, I can give them numbers like MBC. So for a P, which is of course our formula, is given by n, comma, R, which is equals to n factorial divided by n minus 1 factorial, meaning n is the total number of items, which were 3, and then R is the items we want to arrange out of the total number of available items. So in this case, it becomes P into the total number of items, then 2, which is R, is given by n factorial, which is 3, total number of items, divided by 3, which is the total number of items, minus R, this should be R, minus R, which is 2, then factorial. and then this means 3 factorial divided by 3 minus 2 is 3 minus 2 is 1, but now 1 factorial, which means 3 by 2 by 1 divided by 1 factorial is just 1. So it becomes 3 by 2 by 1, which is 6. So I can arrange 2 items, 2 books out of the 3 books in 6 different ways. Can we try another example? So somebody is telling you to arrange 4 students, A, B, C, D, in 2 positions. Meaning, in this case, P, our n, which is the total number of students, are 4, but we only want to arrange 2 out of the 4. Then it's given by n factorial all over n minus r factorial, which means n factorial is 4 factorial because it's the total number of students divided by n, which is 4, minus r, which is 2. Then it becomes 4 factorial. Here is factorial. 4 factorial divided by 4 minus 2 is 2, but now factorial. This means I can take 4 by 3, but then I will say by 2 factorial. Instead of going all the way 2 by 2 by 1, and I already have 2 factorial here, which otherwise here I could just have written 2 by 1, and then just put it as 2 factorial, then divide again by 2 factorial, such that this 2 factorial goes with this 2 factorial, and I only remain with 4 by 3, which is 12. So I can arrange 2 students out of the 4 in 12 different ways. Can we try the last example? It's a real life example where you asked how many ways can you arrange 3 runners to finish the first, the second, and the third in a race. So the first thing you need to note here is you are given 3 runners, so of course n becomes 3, but again you are also told to arrange the 3 of them, all of them, in different ways such that they become as the first, second, and the third. So still r remains to be 3 too. So to do this, you need to have p into n, which is equals to n factorial all over n minus r now factorial. So if I have this, then it will be p into 3 because n and r are the same, is equals to 3 factorial for n, and then n, which is 3 minus 3, and now factorial, which becomes 3 factorial divided by 0 factorial. So up to there we are okay, but how about this 0 factorial? I've told about the concept of 0 factorial in lesson 2, so if you don't know this logic of 0 factorial, you can revisit lesson 2, then you come and finish this example. But basically 0 factorial is 1. It is not 0. So in this case it will be 3 factorial all over 1, which will be 3 by 2 by 1, because 3 factorial is 3 by 2 by 1, then divided by 1, which will be 3 by 2 is 6, 6 by 1 is 6. So you can arrange these 3 runners to be first, second, and third in 6 different ways. This logic of 0 factorial is very important in this in the whole of this mathematics, or the whole of this permutation logic, because not once or twice will you find an issue where at the bottom you get 0 factorial, and then if you don't know 0 factorial is 1, then you might have some issues. So if you don't understand the logic why I'm saying 0 factorial is 1, you can revisit lesson 2, you review, then we'll come into this one. So up to now, I think everything is okay. We can stop this lesson there, and we meet in the next one. We talk about the logic of combination, but the only thing I need you to remember in this one is that permutation order matters. That is not the case with combination. Let's meet there.